In this video, I'm going to explain this fact from last time that if you have two vectors u and v and you take their dot product, that's equal to the norm of u times the norm of v times the cosine of the angle between them. So here are these two vectors u and v. Suppose they have these coordinates. That's the coordinates of u. These are the three coordinates of v. And this formula here is very useful because it allows us to find out the angle theta that these two vectors make. Here's how the proof goes. It's simply the law of sines, and we apply it to this triangle spanned by the vectors u and v, and then this third side is going to be the vector v minus u. Now, v minus u, that's the vector with these particular components, and that's simply we take the components of v, namely v1, v2, and v3, subtract from each of them the components of u, u1, u2, and u3. Now let's remember what the law of cosines says. It says that in any triangle, if you have a side, then the length of that side squared is equal to the other two sides squared, and their sums squared rather, minus 2 times the norm of u times the norm of v times the cosine of the angle between them. This is actually a generalization of the Pythagorean theorem that says a squared plus b squared equals c squared. That applies when this angle theta is 90 degrees, in which case cosine theta is 0, and so you don't see this term. But if theta is not 90 degrees, there is this extra term. Okay, so then let's just plug in everything into these norms. We've seen that the norm of v minus u squared, well, that's just take the components of v minus u, these are these three components, square each of them, and add the result. That's using this formula for the norm. It is you just take the components, square them, and add the sum. So we do the same thing here for u, and the same thing here for v. We square each component and add them. That will give us the norm of, in this case, v squared. And then let's use FOIL, or this rule that a squared minus b squared is a squared minus 2ab plus b squared. Applying that rule to v1 minus u1 squared, we get the v1 squared and the u1 squared plus this cross term negative 2 v1 u1. Similarly for these two terms. And then on the right hand side here, I didn't bother rewriting it, but we have this thing. And what happens is that the v1 squared here is going to cancel this v1 squared on the right hand side here. Similarly, this u1 squared is going to cancel this u1 squared. And so similarly, all the terms that are squared are going to cancel. And what we'll be left with on the left hand side is negative 2 v1 u1, negative 2 v2 u2, negative 2 v3 u3. And on the right hand side, again, all these terms here will have canceled. What we'll be left with is just this, negative 2, the norm of u times the norm of v times cosine of theta. Dividing through by 2's, we get this equation, and then canceling the negative signs, we get this. And so what we see is that the dot product of u and v is the norm of u times the norm of v times the cosine of theta. Okay, I want to do the following problem from Anton. It's on page 154, number 25, and it says a rectangular box has sides of length 10, 15, and 25 units. Find the angle between the diagonal, so here's this diagonal, and the side of length 25. Okay, and so the key is to use the dot product, that involves the angle, and set up two vectors. The problem doesn't tell us what the vectors u and v are, so that's part of the challenge. So one vector is the vector that starts at the one corner of the box and ends at the other, so that's the diagonal of the box. I'm going to choose a coordinate system that has at the origin this corner of the box, and so then this vector u that's in green that corresponds to the diagonal of the box has components 25, 15, and 10. because it's going 25 in this direction, the x direction, if you will, 15 that way, and 10 that way. I could have chosen to set up the coordinate system in a different way. As long as I'm consistent, it's fine. Okay, so then let v be, well, I initially chose v to be the vector 25, 0, 0, so that's in red here, the vector in the direction along the edge of length 25. But to make the math a little bit easier, I chose or changed it to the unit vector in the same direction. It turns out either one of these two will give the same answer. The arithmetic or the numbers will be a little bit smaller here when I use the 1, 0, 0. Okay, so first let's compute the dot product u dot v of these two vectors. Since we're given their components, the dot product, we want to use the second formula here, and the dot product of u and v is 25 times 1 plus 15 times 0 plus 10 times 0, and that all adds up to 25. Next, let's use the other formula for the dot product, namely u dot v is also equal to the norm of u times the norm of v times the cosine of the angle between them. And that tells us that, well, first we have to compute the norm of u. Here's what u is. The norm is you take the square of each component, add that all up. So 25 squared, 15 squared, 10 squared, add that all up to 950, and then take the square root. Similarly, for the norm of v, that's a little bit easier, and we just get 1. And so now plugging in to everything into this formula here, we know from earlier that u dot v is 25. Norm of u is square root of 950, norm of v is 1, and then we don't know, and we're trying to find cosine of theta. So we have this equation where the only variable now is cosine of theta, or theta, and then solving, we get that cosine of theta is this quantity here, and then using a calculator, we get that theta is 35.7 degrees, and that's the answer.